So I want to take a moment to discuss how viscosity can affect our different lavas. So first of all, we need to understand what viscosity is. Viscosity is just the resistance to flow. So how easy or how hard things flow. So when we talk about viscosity, we compare everything to water. Water has a viscosity of 1, right? We compare it. So anything that has, say, a higher viscosity is going to be really sticky, like molasses. Anything that has a low viscosity is going to be more runny. So just keep that in mind. Don't get those two confused. So when we talk about our different magmas, right, or even our different lavas, we can talk from our felsic end to our mafic end. So our felsic end has all of that silica and oxygen. So we have all of those tetrahedras, right? Remember talking about that in chapter 5? All of those silica oxygen tetrahedras in that system. This is a big molecule. Because it's a big molecule, it kind of gums up the system. Just like if you have chewing gum in your pipes at home, right? It makes it really hard for that water to go through. That water has to have a whole bunch of pressure to get through there. So because of that, okay, our felsic, the more silica oxygen you have, the higher the viscosity. The stickier it is. It needs much more pressure to push it out of there. So we're going to see in our next chapter, this is going to make our explosive volcanoes. Now, our mafic, on the other hand, okay, this is full of iron and magnesium. It doesn't have all those tetrahedras gumming up the system. So this has a low viscosity. So this can run. Not quite like water, but it's runny compared to felsic. So we're going to see that our mafic volcanoes tend to be much more passive. They're not as angry. They're not as explosive.